We present a method for interactively controlling kinematic characters that perform user-specified tasks from a small number of example clips. Our method first uses the example clips to learn a low-dimensional space that captures a continuous range of character motions. We then pre-compute a controller that navigates this low-dimensional space to accomplish the desired task. At runtime, this pre-computed controller can produce responsive interactive characters that appear consistent with the example clips. Our method can produce a walking controller from as few as 2 clips. While additional clips can further increase its agility. By using different training data, our method can produce walks in different styles. This character exhibits a more aggressive walking style. We also tested our method with a small running dataset. As well as a larger running dataset that contained more turns. Here, we show a controller trained from artist-created dinosaur animations. Artist-created motions of a dragon, and of a horse. Our method can also handle more complex tasks such as punching. The target lights up when the character receives a reward. When the user moves the target rapidly, our controller can successfully track it. By using different training motions, we can produce a punching controller with a different, more cautious punching style. Or a more aggressive style. We can also train a controller for kicking. This previous method exhibits visual artifacts with small datasets and requires 5 times more clips to produce good results. While a discrete graph-based controller does not exhibit the responsiveness of our continuous method. With 4 examples, our method becomes even more agile compared to the discrete graph controller. But without the proposed connectivity term, it cannot utilize all available motions. On the more complex punching task, the connectivity term becomes critical for good results. Motion fields cannot accomplish this task, while the discrete graph controller cannot effectively pursue the target with so few example motions. Because our controller is continuous, it responds immediately to user input. Note how the character aborts the turn when the desired direction changes. Similarly, the punching character can adjust the arm mid-punch. Note how the hand follows the target as it is moved out of the way. The current task can be changed by switching controllers. In this way, we can switch between walking and running, or between punching and kicking. Note that the switched controllers are trained on different motion data. We can also apply constraints to the character during synthesis. Here, the character's limbs are prevented from intersecting the cylinder, producing a more plausible animation. Constraints can also alter the behavior. Here, the left hand is constrained to hold the pole. No additional motion data was used. The walking character can also be constrained. Here, the previously shown walk is constrained to hold the hands on the hips. And here, the character is constrained to point a weapon at a target. Again, no additional data was used.